In this video, we are going to introduce exponential functions and how to graph exponential functions. So part A, we are going to graph linear, quadratic, and exponential functions in the same grid given by using table of values. And also from table of values, we are going to see the special properties for linear, quadratic, and exponential functions. So f at x equals 2 times x, we create a table of values. We give the x value -2, -1, 0, 1, 2, 3. You could give x other numbers, but we would like to graph the y equals to x around the center of this grid given. So the center of the grid given x equals 0, so we pick the other points around the x equals 0. So that is the reason we pick the x value -2, -1, 0, 1, 2, 3. So for the table values, how to find the y value is substitute the -2 to x. So the first one is 2 times -2, and this f at x is equivalent with y, so they are interchangeable. F at x, we call it function notation. It's not f times x. The function's name is f, and x is input. So 2 times -2 give you -4. 2 times -1 is -2. 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 give you 6. So this each x and y give you 1 point on the graph. So this is we call table values. And we want to find the first difference. First difference is same as the rise. So it's a difference of y. So -4 to -2 is up to. So you just subtract -2 minus -4 give you +2. So from -2 to 0 is up to. So you will see all the rise, they are same. You have up to here. And for the run will be the difference of x. So from -1 to -1, -2 to -1 is up 1. So -1 to 0 up 1, 0 to 1 up 1, 1 to 2 up 1, 2 to 3 is up 1. So from here you will see the rise over run equals 2. So it means on this graph, all the rise over run, they are same. So they have the same slope. It is a straight line. And we call this is linear equation, linear function. So linear functions, how to determine it from table values is the first differences are same. The differences is for the difference of y, subtract y, are same. Then it means rise over run same, so you have the slope same. It is a straight line. And for the g at x equals x squared, also g at x function notation is interchangeable with y. So again, we pick the x value around this center of this graph, and this works only for the parent function. So this one, although it's not parent function, so but it is no left, right, up, down transformation, so we still pick the points around this 0. So this is y equals x squared because this is parent function of the quadratic function. So the parent function is the simplest function, and most of the time it is around the origin 0, 0 point. So we pick the x value around this 0. So put the -2 into x, we have -2 squared is 4. Then sub in -1, -1 squared is 1, 0 squared, 0, 1 squared, 1, 2 squared is 4, 3 squared is 9. So each row is a point, -2, 4. And we try to find the rise of the y. So difference of y from 4 to 1 is down 3, 1 to 0, down 1, 0 to 1, up 1, up 3, up 5. And you will see the run is still up 1, up 1, up 1 is same, but rise over run this time is not same, so it's not a straight line. Then we want to find the difference of the first differences. The difference means subtraction, so it's minus. It's y value minus. So -3 to -1 is up to, -1 to 1 up to, 1 to 3 up to, 3 to 5 up to. Then we know that is a quadratic, and the property is the second differences are same. So second differences means the difference of rise are same. So if from table values, if you are able to find out that the second differences are same, then we know this set of data is quadratic relation. So the next one, we call it exponential. Why we call it exponential? Because we have variable at exponent. Then we call this type of function exponential functions. So -2 is subbing 2 to the exponent -2. We do the flip. Negative exponent is reciprocal of the positive exponent. 2 squared give you 4. So 1 over 4, then 1 over 2 to the exponent 1 is 1 over 2. And 0, 2 to the exponent 0 is 1. 2 to the exponent 1 is 2, 2 squared is 4, 2 cubed is 2 times 2 times 4, give you 8. Then we want to find the difference. So from quarter to half, it's up quarter. From 1/2 to 1, up 1/2. And from 1 to 2, up 1. From 2 to 4, up 2. From 4 to 8, up 4. Then you will see if we continue to find the differences, it will repeat quarter, half, 1/2, 1, 2 again. So you will never ever get same. So then we want to find the first ratio. So we are going to, from the y value, we do the division. So 1 over 4 to 1 over 2. So we do the division. Then 1 over 2 divided by 1 over 4, it will give you multiplication by flip the dividend. So it will be 4 over 1. We are going to switch the, once we change it to multiplication, this dividend we need to reflect. So flip it. Then 1 times 4 divided by 2 times 1 give you 2. So that is a ratio. Do the division. 1 over 2 divided by 1 over 4. Then 1 divided by 1 over 2 give you 2. So it's a differences. Then 2 divided by 1 give you 2. 4 divided by 2 give you 2. 8 divided by 4 give you 2. Then you will see for exponential function, the ratios, the y value divide, that they are same. So from table values, how we can determine its exponential function, we are going to find the first ratio, the division, to see if they are same. Ratios same, then we know that is a exponential functions. And this one again applied to the parent function. So parent function means only the base to the exponent. We don't have adding, subtracting to this parent function. The simplest function in that family, we call it parent function. Now we are going to graph these 3 graphs on the same grace. So -2, -4 is 1, 2, 3, 4, 5, 6, 7, 8. So -1, -2, so -2, positive, -4, sorry, is out of the grid. Then we pick the next point, -1, -2. So this is -1, -2, then next point 0, 0, then 1, 2, 2, 4. Then we could use a ruler to a straight line to connect them. So this is a y equals 2x. So that is a straight line. Then we are going to graph the next one, y equals x squared. So -2, 4, -1, 1, 0, 0, 1, 1, 2 squared is 4. So we have this U shape. This is y equals x squared. Then after that, we are going to graph the exponential function. So exponential function is -2, then quarter will be quarter of this grid. -1/2, middle of the grid. 0 is 1, 1 is 2, 2 is 4, and 3 is 8. So then you connect these points. So this is y equals 2 to the exponent x. When compare these three graphs, you will see linear is a straight line and x squared is a U shape, and y equals 2 to exponent x is a graph that from left to right is increasing and it's increasing faster and faster, quicker and quicker. And also it will never ever across the x-axis, because 2 to the exponent x is going to be positive. When x is a negative big number, it will be closer and closer to y equals 0, but it will never ever across it. So this is we call the asymptote, horizontal asymptote for exponential function. So these are the three graphs: linear, quadratic, and exponential. So from table values, linear first ratios are same. For quadratics, first difference is not same, but second differences are same. For exponential, no differences same, but the ratios are same. Now we are going to graph more exponential functions. So this one, the base. This 3, we call it base, and x is at exponent. And this one is called parent function in y equals 3 to exponential to the exponent x. This exponential family's parent function. So we sub in. You have 2 to the exponent 3 to exponent -2. It will be 1/3 squared. It gives you 1/9. And next one, 3 to exponent -1 is 1/3 to exponent 1 is 1/3. And 0, anything exponent 0 is 1. So 3 to exponent 1 is 3, 3 squared is 9, 3 cubed, 3 times itself, 3 times is 27. Then we could try the differences. You will see it will be 9, 3, 2/9. And this one 2/3. This one 2, this one 6, this one is 18. And if we do the subtraction, it won't be same. So we are going to see the first ratio, 1/3 divided by 1/9. It will be flipped 8 2 times 9/1, so the final answer is 3. Then we continue to do the division. You will see it's just same as a base. Then 4 to the exponent x, we sub in 1 over 4 squared is 16. 1 over 4, 1, 4, 4 squared, 16, 4 cubed is 64. Then first difference is not same, so we don't bother to check it. The ratio 1 over 4 divided by 1 over 16 is times 16 over 1, so it will be the base 4. So we just do the division. You will have the ratios are all same, is 4. Then we do the graph. So it's -2 very close to the 0, then -1 1/3, 0 1 1 3, 2 is 9, and 5 points we could graph it by connecting them. So this one is y equals 3 to the exponent x. Keeps going, and also we draw the horizontal asymptote. This graph is getting closer and closer to this x-axis, but it will never ever cross it. Then 4 to the exponent x, it will be smaller, lower than this 119, so it's -2, 1 over 16, -1 quarter, then 0 1 same, 1 is 4, 2 is 16, so it's go up faster. So you just connect them, it will be steeper. So it will be just more smooth. So y equals 4 to the exponent x. From these two graphs, you will see if the base is greater than the graph after x equals 1 is getting steeper and steeper. Then we are going to see if the base is less than 1. So this one is increasing. From left to right, it's going up, so the graph is increasing. Then we are going to see the base less than 1. So 1 over 2, we sub in 1 over 2 to the exponent -2. We could convert it to positive exponent by flipping the fraction, so you will have 4. Then -1 flip, 2 over 1 to exponent 1 is 2. 0 to anything base to the exponent 0 give you 1, then 1 over 2 to the exponent 1 is 1 over 2, then 1 over 4, 1 over 8. The first difference is not going to be same. The ratio is division 2 divided by 4. It will give you 1 over 2. And 1 divided by 2 is 1 over 2. So it will be same as the base. And 1 over 3 is 7, flip is 9, 3, 1, 1 over 3, 1 over 9, 1 over 27. First difference is not going to be same. Do the division, 3 divided by 9, it will be the base 1 over 3. So all the ratios division will be same. Then we are going to use the xy as 1 point to do the graph. So -2 is positive 4. Then -1 is 2. 0 1 same. 1 is 1 over 2. Then 2 is 1 over 4 is quarter. So this is y equals 1 over 2 to the exponent x. Then use the table values to graph y equals 1 over 3 to the exponent x. Then we use these table values to find the points on the graph. So first point, negative 2, 9, 4, 5, 6, 7, 8, 9. Then negative 1, 3, negative 1, 3, 0, 1, 1, 1/3, and 2, 109. Connect those points. This is y equals 1/3 to the exponent x, and again they have a horizontal asymptote y equals 0. This graph will get closer and closer to y equals 0, but will never ever cross it. So the base 1/3 to the exponent x means each time you times 1/3 a number less than 1, so the y value will get smaller and smaller. But because it's a positive number times itself, so it will never ever get negative, so it will never ever cross the y equals 0. And a non-zero number divided by another number won't give you 0, so it will not equal to 0. So from the above graphs, you will see this one from left to right is going down, so it means it is decreasing. We call this decreasing. So how to determine decreasing or increasing from left to right? To see if the graph is from left to right, the graph is going up, then it's increasing. If the graph is going down, then it is decreasing. And also from here, you will see if the base is less than 1, so each time you times a number less than 1, so the graph is getting smaller and smaller. And if the base is greater than 1, you times the number that is greater than 1, then the y value will get larger and larger. So what do you notice about the domain, range, asymptote, and y-intercept of the graphs above? So we are going to see the domain, there's no restrictions for the x. So the domain will be the x belongs all real numbers, no restrictions for x. It's from negative infinity to positive infinity. And for the range of them is y is going to be positive and will never ever cross the y equals 0. So also you could use the interval notation is 0, infinity, and this one is negative infinity to positive infinity for domain. And for the asymptote, you have a horizontal asymptote. Horizontal asymptote that is y equals 0 for parent function. Parent function means you don't have adding, subtracting, it's just y to the exponent, y equals base to the exponent x. This is we call parent function, the simplest function. And if we write it as general form, it's a times b to the exponent k bracket x minus p bracket plus q. So this is a function f of x. Then the general form is a function f bracket k bracket x minus p bracket plus q. The parent function is a equals 1, k equals 1, no vertical stretch, no horizontal stretch, the shape doesn't change, and p is 0, q is 0, so there's no left right. And here is 1, b to exponent 1, x minus 0 plus 0, so a k p q, a k 1, p q 0, so this is parent function. and the y-intercept. Y-intercept means the point of intersection of the graph with y-axis. On the y-axis, x is always 0, so we sub in 0. b to exponent 0 always give you 1. So you have a common y-intercept for all these parent functions. So these are the properties for the exponential functions. Exponential functions means the variable is at exponent. So we are going to see more graphs. So this one will fall to exponent negative x. We could write it as fall to exponent x. That will be same as a graph on the first page, same as this one. Part B, 2. So it's same as part B and function, second function. This one we could write it as 1 will fall to exponent x, flip it. So we could sub in this one 1/16, this one 1/4, 1, exponent 1 here is 4, 16, 64. Then this one is just the flip of this one. So it will be 16, 4, 1, 1/4, 1/16, 1/64. So we find those points. -2 will be close to the y equals 0, then quarter 1, 1, 2, 3, 4. Then 16 will be up, outside of this grid, so it's just y equals 4 to exponent x. That is, base is greater than 1, or we could write 1/4 to the exponent negative x. So it is increasing because we flip it 4/1 to the exponent x. You have the base is greater than 1, so it's increasing. And for this one, we flip it, it's 1/4. And also we could think that is comparing to 4 to exponent x is 4 negative x minus 0 plus 0. So the a value is 1. So this one, it will be the k is -1, so we know k is -1, it will be the reflected in the y-axis. So it's just those points flip. So -2 becomes +2, so these two will be the same value. So this one, -1 becomes +1, 0, 0. This one, flip, it will be -1 and 4. We connect them. So this is y f x equals 4 to the exponent -x. It's just reflected in the y-axis. One is increasing, one is decreasing. And also we are going to graph this horizontal asymptote. So these two graphs will approach y equals 0 closer and closer, but never ever cross it. So f at x equals 1 to the exponent x. We sub in 1 to the exponent -2, give you 1. Then you will see if the base is 1, then you will have a horizontal line. This is f at x equals 1 to the exponent x. So we are not going to discuss about base is 1. So for the exponential function, base either greater than 1 or less than 1. So f at x equals 0 to exponent x It's undefined because we don't have 1. This is a 0 to the negative 2, then you will have 1 over 0 to exponent squared. It's undefined. Because we don't have the denominator, we couldn't have denominator equal 0. It's undefined. 0 to exponent 1, it will give you 0. So it kind of, you have a graph that is so this x couldn't be negative, because if x is negative, we could do the flip. It will be 1 over 0 to the exponent x. Then 0 is a denominator, is undefined. So x couldn't be negative. And also if x equals 0, 0 to the exponent 0, you have the self-divide still undefined. So we know that x couldn't be 0 and x also couldn't be negative. So the domain, the divided x value will be positive. So f of x equals 0 to the exponent x, and the domain is x belongs to all real numbers such that x is greater than 0 but not equal to 0. So now we are going to see what if the base is negative. So the base is 0. Now we are going to see what if the base is negative. And here is negative 0.5. This is 0.5. And this is 1.5. So negative 2 to the exponent negative 1, it will give you flip 1 over negative 2. And this one to the exponent negative 0.5 is 1 over 2, so we flip it, is 1 over negative 2, then 1 over 2. It is a square root, negative 1 over 2, and use your calculator, you will find out this is undefined. So the number doesn't exist in real number. And 0, negative 2 to the exponent 0 give you 1. So negative 2 to the exponent 1 give you negative 2. Negative 2 to the exponent 2 give you positive 4. So they are nice number, but what if is 1 over 2? So this one, negative 2 to the exponent 0.5, it is same as square root negative 2, is undefined. Square root of negative 2 means you are looking for two numbers, they are same, times together equals negative 2. So there's no number squared equals negative 2, so that's the reason it's undefined. 1.5 is negative 2 to the exponent 3 over 2. So it will be square root negative 2 to the exponent cubed. Again, it's a negative number squared root, so it's undefined again. Then if we graph it, you will see that the graph is not continuous. So negative 1, we have negative 1 over 2. This is 1 point. If integers, then it's okay. X equals 0 is 1, x equals 1 is negative 2, and if x equals 2 is positive 4. So we have these 4 points, but for the other points is negative 0.5 undefined, and 0.5 undefined, 1.5 undefined, so the graph is not going to be continuous. And this one also give us some restrictions for exponential functions. For exponential functions, y equals b to the exponent x, the base need to be greater than 0. It couldn't be negative. The reason is if x is 1 over 2, then you will have a square root. and if b negative, it's undefined. And now we are going to see some conclusions. What value of b will result in a smooth curve of an exponential function, that is b greater than 0. If b less than 0, then some points is undefined. What value of b will result in exponential growth and decay? So if b greater than 0, you keep multiplying a number larger than 1, the function f of x is going to exponential growth. And if b less than 1, b to the exponent x means you keep multiplying a number that is less than 1, so the function is getting smaller and smaller. We call it decay. And if it's b to the exponent negative x, then we know that is if this one is y equals b to the exponent x, then the negative x means it's flipped in the y-axis. So before, if it's a growth, now you flip it. Before it's growth, then you flip it in the y-axis, will be decay. And before it's decay, you reflect it in the y-axis, it will give you growth. So they are opposite. So next page we are going to, this is all for parent function. Then next page we are going to discuss about transformations from parent function to other functions. So this is a general form. Parent function f of x equals b to the exponent x. A k p q equals a k equals 1, no vertical stretch or horizontal stretch, and p q equals 0, no left right. We call this is a parent function. So this is a times b to exponent, the x k bracket x minus p is horizontal stretch and the horizontal shift. Q and a are the vertical stretch and the vertical shift. So compare this one with this function. So we are going to see the parent function is just the b to the exponent x, base to the exponent x. So this is 1 over 3 to the exponent x. Then rewrite this one in forms of f of x. We are going to change it to 1 over 2 times function f. The exponent we put here, that is we sub in, you will have 1 over 3 to exponent x minus 2. It will give you this part. Then minus 4 is outside of this function f of x minus 2. And this one, base to exponent, is your parent function, and g of x in terms of f is f of x is 3. Then this whole thing is function f input x plus 5. I put x plus 5 here, give you 2 to exponent x plus 5, then minus 1. So compare this one with, we also could write it as a f k bracket x minus p bracket plus q. This one, compared it with this general form, we are going to see the a equals 1 over 2, k equals 1, p equals opposite 2, q equals negative 4. So using this AKPQ to fill in the descriptions of transformation template. So the graph of parent function is 1 over 3 b to the exponent x is vertically stretched by a factor of a value, positive only, and because it's positive, so no reflect. If negative, it will be reflected in the x-axis. Then horizontally stretched by a factor of 1 over k. 1 over k is 1, so it's no horizontal stretch. And reflected, there's no, not negative, so no reflect, and translated p-value right, left. P is positive, so it's right. 2 units right and 4 units down. So on the blanks, all positive number. If negative, we use reflect or left down to describe the negative. And for this one, vertical stretch by 3, and again no reflect, and horizontal stretch by factor k is 1 again, and you don't have to write the horizontal stretch if it's 1. So, and translated is p is -5, q is -1, so a is 3, k is 1. If k is 1, then no horizontal stretch. Only not 1, we have the stretch. Translated 5 units, 5 is negative, we put left. And q is negative, is 1 unit down. So now we are going to base on the descriptions to do the graph. So this one function is 1/3 to the exponent x, and this one is 2 to the exponent x, and we copy the AKPQ here. So A is -1/2, K is 1, P is 2, Q is -4. And this one A equals 3, K equals 1, P equals -5, Q is -1. And we are going to, we could use 2 methods to graph it. One is based on the parent function, we do the stretch and the graph together. So sub in 1/3, -2 is flip, 3 squared is 9, 1, 3 to the exponent 1 is 3, 0 is always 1, then 1/3, 1, 9. So this is parent function, and the transformation is from this one. We do the a times y value plus q. It will give the new point. And for the x is x, do the opposite, divided by k plus p. So ay 1/2 times y value, then -4. So this one times 1/2, 4.5 minus 4 give you 0.5. Then sub in 3, 1/2 times 3 minus 4. It gives you -2.5. 1 is 1/2 times 1 minus 4. It's -3.5. Sub in 1/3 is 1/6. Minus 4 give you -3 point, this is 1683. Then this one 1/9, so 1/2 times 1/9 minus 4 give you -3.9 something 5. So these are the points, new y points. And for the x, -2 divided by 1 divided by is just nothing, so just +2 is 0. So all these numbers +2, 1, 2, 3, 4. Then you could use this new point to do the graph. So x equals 0, y equals 0.5, and x equals 1, y is -2.5. Then x equals 2, y equals -3.5, x equals 3, 3 point something, and 3.95. And before we have the horizontal asymptote y equals 0, now it is downfall. So the new horizontal asymptote will be y equals -4. So we are going to draw y equals -4 as a new horizontal asymptote. Y equals 0 only will be affected by the q value, because a times y, 0 times a value give you 0, so only minus q plus q will change this y equals 0 line. Then we connect them. This is your new graph. So y equals 1/2, then 1/3 to the exponent x -2 plus -4. So this is a ZX, or you use y is okay. So this is a new graph. Now we could graph the second graph by using the parent function and also using the AKPQ to do the transformations. So for the second one, we are going to take the x value around the 0 for the parent function. So it's -2, -1, 0, 1, 2. Then if we sub in the -2 to 2 to exponent x. So 2 to the exponent -2 give us 1/4. Then do the same thing, 1/2, 1, 2, and 4. Then the new y value, it will be ay plus q. So it's just 3 times y, then -1. So this is a function 3 times 2 to the exponent x plus 5. So 3 times y minus 1. And for the x, it's a divided by k plus p. K is 1, so it's just p. So it's x, sorry, x divided by k, x divided by k is x divided by 1, p is -5. So it's just x minus 5. Then we are going to see, so a 3 times y, this is a y value, this column is y value minus 1, we have -1/4. Then we sub in 3 times 1/2 minus 1, we have 1/2. Then 1 times 3 minus 1 is 2. Then 3 times y is 2 minus 1 is 5. Then 3 times 4 minus 1 give you 11. So these are the new y value. And for the x value, it's just x minus 5. This column minus 5 is -7, -8, -5, -4, then -3. Then they are the new points. So it's a -7, -1/4. And also the new y equals 0, the horizontal asymptote becomes y equals q, y equals -1. So we are going to draw a line at -1. So this is your new y horizontal asymptote. The whole graph will be above this y equals 1, -1 horizontal asymptote. Then the first point is -7 quarter, -6 half, -5 is 2, -4 is 5, and -3 is 11. It's out, so it's just I think the first point is not perfect. It's -1/4. So we connect them. this is a function that is a g at x equals 3 times f, 3 times 2 to the exponent x plus 5, x plus 5 then minus 1. So this is a graph. So in this video we showed you how to graph this one by using the table of values, and also you could use other method by graphing the parent function 2 to the exponent x, then do the stretch, then move it around. But using the table of values may help you to understand what's going on to the point. So and from these two graphs, we are going to see if the base is less than 1. If the A and the K, there's no reflections, it will be decreasing. If its base is positive, is greater than 1, if AK no reflect, it will be increasing. And the horizontal asymptote is y equals q. And the p-value is opposite. So this one 2, right 2. This one plus 5 is left 5. Thanks for watching.